So I'm just gonna go through a list of things, do a demonstration or two. We'll actually cut some wood, and then give you some ideas about how to handle some unusual circumstances. Okay, first thing. This is a fence. You use the fence when you don't have a bearing bit, and you can use it with a bearing bit. However, we just replaced these knobs last week because somebody, yet again, torqued them down too much and stripped the rods going in. Getting these things was a royal pain in the butt. They're made in China, and you buy them from Jessam, which is the maker of this machine, and Jessam is a Canadian company. You cannot get anything from Canada these days. So, because Dave Hunter is a Canadian citizen, he called his brother up and said, can you order this for us? And I got two versions of this. But if you see how much I just twisted this a little bit? And this is not moving. You don't need to put a lot of pressure on this thing. These are not cheap and they're not easy to get. I did buy two copies, two versions, so that if we do have it, but we're running on borrowed time if we continue to over. Now, contrary to some people's belief, the fence does not have to be parallel to anything when you do a cut on a router. Okay, you can literally have the fence like this. Well, if it would allow me, and and it will still give you the same cut as if it was perfectly, because it's a point on the fence. That's it. You're cutting in one spot. It doesn't make any difference. Okay. Speed control. I want to talk a little bit about that because we don't do enough. The speed control is down underneath here. You can see it later, but it's pretty straightforward. It's got it marked. It goes from 1,200 to 21,000 RPMs, okay? And why would you need speed control? Well, the bigger the bit, the slower you're gonna want it. So I brought a couple of samples. See this guy right here? When that router is spinning at 21,000 here, what it's doing out here is a significantly higher. So it is going way too fast. And if you're trying to cut white oak with it, it's even worse, okay? In the drawer right here is a speed chart, okay, for anybody's use. You use this to determine what your speed is. Now, these don't match the speeds on this, but it'll give you an idea, okay? So if you're talking about a 3.5 inch, it wants to be down at 10,000 RPMs, okay? This is another one that I often use, and we have to torque it way down, okay? These are my bits, and we don't have anything this big, but we do have bits that are bigger than the others, and just consider that, all right? And if you're cutting pine, that's going to be a little bit easier than cutting a piece of white oak. When you do torque down the speed, it ramps up. So it'll start at the highest speed, and then you can hear it go down. Here, let me give you an example. I'll show you what this is. So I'm going to move it down to the lowest speed. And if I turn this on, so wait for that to happen before you start moving. Everybody hear that? So, everybody knows that this is the depth adjustment for the router, okay? Make sure that you unlock the lock before you move it, okay? And you can move it, but it just damages the machine if you don't. So just make sure you keep the lock off when you're moving it up and down, and then, of course, lock it back in when you're done, okay? Okay, installing bits. The standard default collet, that's the thing that holds the bit, is the 1/2 inch bit, the 1/2 inch collet. In here is a 1/4 inch collet. So if you have a bit that's a 1/4 inch shaft, this is a 1/2 inch shaft, Okay, make sure you change this, and then put it back. Don't leave the 1/4 inch collet in there. And it's just a matter of, this thing comes off, and goes back on. So, pretty straightforward. Always use a throat plate. Now, I always use the word always. There are a couple of cases I could not use a throat plate with this bit. Okay, so, but again, there isn't any bits in the shop that would have that problem. If somebody borrows this from me, I'm going to watch them do it and show them how to use it. So I'm going to cut a couple of, make a couple of samples. So go ahead.
Before you do that, can you talk about adjusting the face of it? Because if the bit is too big.
Yeah, and I don't have that on my list, but you're right. See, these things, and actually these don't move enough, in my opinion. These little locks in the back, so if in fact you were using this bit, you need to have enough space in there to clear that bit inside of there. Now I like to keep it as close as I can so that it takes more of the dust away, okay, if you can. But Rich is right, you need to keep that to a point where you're not hitting the bit on this fence, okay? I actually have in my home router, I have the ability to change the fence. So I have ones that are solid all the way across, and then what I do is I make a zero clearance hole for it so that it's buried into the fence and it's exactly the shape of the bit. Okay, so I'm going to put in a bearing bit. Okay, there's nothing magical about this. So I bottomed that out, never leave it bottomed out, bring it up a little bit, okay? Now you can't put the throat plate in yet because it's too hot, so bring the throat plate down, the bit down. That throat plate I think is too. Now, everybody understands that when you're using the bearing bit, you don't need the fence. You can use it if you want, but the bearing is what controls the piece of wood and through the cut. You are running the bearing along this edge, okay, and that's what controls the ability to not have it fly off or what have you, okay. The danger of that is if you look really carefully at this piece of wood, okay, see that X? That was a mistake, okay? But there's a bump there. So when I put the profile on this and that bearing hits that bump, it's gonna come out on the edge. So now the fence is controlling the depth of the cut. And when I hit that bump, it won't be as noticeable on the edge. Okay. Depends on what I'm doing. I would say 75% of the time, I don't depend on the bearing. I actually use the fence to control my cut. Now, this is called a pivot pin. It's in the box right here. This helps you control starting your cut, okay? If you have a long piece, you might not need it as much, but in something like this, I would tend to use it. The way you use it is, you screw that in, you screw it. Okay, so what I'm going to do is I'm going to put my workpiece here and then use it as a pivot to go into the bit until I hit the bearing. Okay, now once you've started the cut, you can ignore the pivot. You can just use the bearing. You can move it away, but that's a way of starting the cut in a controlled way. So you have a little bit, the shorter the piece of wood, the more important that pivot pin would become, okay? I'm not gonna take a lot off of this. Somebody wanna hit the... After I was, a couple of inches down, I moved the piece away from the pivot and used just the bearing. If you try to hit them both at the same time throughout the whole thing, you might tend to not hit the bearing as much, okay? So it's just better to get it in there and then just move it away and finish it with the pivot, with the bearing, okay? Any questions about that? I don't know where this is in my list, but you'll notice how little bit of a cut I made. And that's clearly not as much as I would normally take off. The way I do this, and the way I think it's best for everybody, is if you've got a bunch of these that you make a profile on, always have one or two exactly the same ones that are used as a test, so that you can set the bit, use your test and say, okay, that's good, and then do all your other ones. And then, okay, I want to go a little deeper, go back to the test. And the objective here is that as you move it up, if you move it up a little bit too soon, too far, beyond your where you want to be, then you're going to end up ruining good stuff without your test. Yes?
The other thing is, depending on the hardness of the wood, you may not want to try and take it all in one pass.
Well, that's what I was just saying.
No, but apart from getting it to the right cut,
right,
you also, if you feel you've got it right, even if you work up to the right thing, you still may want to do it in several passes.
Absolutely.
Because if you've got a really hard wood, it's going to be difficult.
This is poplar, it's pretty soft. I would probably go 3 or 4 times through this. If it was white oak, I would do it twice as many times. And the last cut, if you can work on it, it should be the smallest of the cuts, because that's going to give you the smoothest result.
Richard, how about using a push stick for small pieces? That coming up?
So for small pieces, yes, you can use this push stick. Particularly, not so much for they're short this way, but for skinny ones that are long, then you want to use a push stick. And there are feather boards in here to help you keep it against the fence. Okay. But when you get something this short, you obviously can't control this by hand. So this is the trick I like to use. Okay, put it in a hand vise like this. Now you have, you don't need this. Now you have complete control, and make sure it's tight, obviously, and you can go through that. And it won't go anywhere. And your fingers are well away from the cutter. Okay. I use these hand clamps a lot, and they're good for the miter saw as well. One that's not a bearing bit. By the way, this is another area where you don't want to over tighten, although I have had cases where it has moved. So you do need to put a bit of torque on it, but don't overdo it. And again, I'm not bottoming the bit out, I'm just putting it down with a little bit of space on there. Now, in this case, you're taking a bit of wood with that cut. So if I try to go 1/4 inch deep, That's a lot for that machine to cut. So what I'm going to do is, I make a slot right there. I'm going to pull these down, just like that. And if you look at this, that's going to be a big bite. So I'm going to move it way, way down. And this is part of the problem, the reason I want to rebuild, because I think I should be able to go lower than that. And the machine won't let me. So I think it's set in there incorrectly. But that's another issue, okay? But that's not too bad, okay? So I'm going to move that thing through there, okay? And it's enough so that I can, you know, this is one of the ways I do this. You could do it this way or this way. I like this the best, okay? Personal preference. I can't tell you why, but this keeps it against the fence and your fingers well away from the bit, okay? I'm going to go moderately slow, but not too slow, because you don't want to burn things up. If you're pushing it through and it's hard, it means you're taking too much off at the time, almost always. This would be much more difficult with white oak than it is with poplar. Okay. And so what do you do? In my opinion, that was too much of a bite. I wouldn't normally have done that, but again, that's as low as I could go with the router. And hopefully we'll get that fixed, okay? So this is a great dado. The problem with dados on the router is I'm stuck with just certain widths, that's it. And most plywood doesn't match, so that's why I almost always use my dados on the table saw, but this can work. Okay.
You use it for like a sliding dovetail.
Yeah. Now, that is a flat-bitted bit for dados. We do have a set of spiral bits. It's on the bottom drawer, okay? The spiral bit will give you a cleaner cut, more smooth. It just is a better overall bit. So if you have a choice, and these are standard bits. So you got a 3/16, a quarter, 5/16, 3/8, and a ½ inch. Okay. If I have a preference, I always go with a spiral bit. If it's available. One note about direction. You'll notice as I told you before, you always go from the right to the left on the router table. Okay. However, the objective, and you never put something behind the router bit. Okay, it's always got to be in front. Okay. Now, let's say I wanted to put a profile on the inside of this. Okay. So you notice that I put little arrows here. If I'm putting the profile here, I'm going to move it just like I did before, from right to left. However, if I'm putting the profile inside, I'm now going to turn it in this direction, okay? Which but I'm going to be like here. The fence has got to go. There's no fence there, and so you have to turn it in a direction that moves the bit inside, okay? Pulls the bit into it, okay? Almost always I get confused myself when I do this, and I start very slowly, and it tells me right away if I'm going in the right direction or not. Okay. But just keep in mind that the rule about right to left is 99% of the time correct. So you try to do something fancy like this. Okay. So we have a set of these they're 1/4 inch shanks, and they're spiral bits with the bearing at the top and the bottom. So you can kind of figure out which is most advantageous for you. And these are really great for doing flush trim bits. They're spiral. They run really nicely against at the edge. They can be used with the fence, like I described. And there's 3 sizes, and they come out looking very nice.